Hello friends, welcome to the session on the data structure. In this session, we'll be discussing about the data structure called as a stack. You must have been visited the library and you will find that library consists of large number of books. And you must have been observed that in the library, the books are stored on one another. So when you put the books on one another or when you put the things on one another, then it is just nothing but a stack. You will find that most of the concepts that we use in the computer science are taken from the real life only. So people must have been observed initially that people stack the things in the houses or people stack the things at the working places. And this concept is being borrowed into the data structure to create a data organization called as a stack. So stack is a very useful data organization and programmers can make the use of the stack in various applications. So friends, as you know that we are recording this session for PSS Central Institute of Vocational Education, and this session is being recorded for the course Junior Software Developer. You will find that the students from other courses also can make an access to it so that they can learn data structure. Learning of data structure is very important because if you want to become a good programmer, then the first step towards the good programming start from the data structure itself. So let us understand in this session what we mean by stack. In this session, we'll be discussing about another useful data structure called as a stack. So stack is just nothing but the collection of data elements where the insertion and deletion will take place from one end only. So as shown in this diagram, one can easily observe that we have a cylinder type structure, and this cylinder type structure is being called as a stack, where you can insert the element from one end and from the same end you can remove the element. So there is one end open and the other end is closed, and therefore whatever you want to insert into the stack, you need to insert it from the upper end only, and whenever you want to remove some element from the stack, then that element is also removed from that end only. So there is only one open end, and therefore whatever the operation that you want to perform on the stack, such as insertion operation or deletion operation, that is adding an element into the stack or removing an element from the stack, need to be performed that end only. And such data structure is being called as a stack. As I told you, this concept is taken from the real life. So whenever you put the notebooks or books on one another, then they form a stack. And therefore, whatever the last book that you have put in, that you can pick up first. And whatever the first book that you have kept will go at the end. So stack is like this. If the element is inserted into the stack, it will go at the end, and the last element will be on the top of the stack. But this is very useful data structure, and you will find that many algorithms actually make the use of the stack for finding the solutions. Sometimes we call the stack as the last in first out. That is, we call the stack as the LIFO, last in and first out. So whatever is the last inserted element is there, that will be removed from the stack, and therefore that is being called as a last in and first out. So stack is a linear data structure. Just like an array, stack is also a linear data structure where the elements are stored linearly, or you can say that the elements are stored sequentially. Now, whenever we want to insert the element into the stack, then this operation of insertion into the stack is being called as a push operation. So push operation means insertion of the element into the stack. And whenever we want to remove some element from the stack, then this operation is being called as a deletion operation, and it is popularly known as pop operation. So whenever a stack memory is being given to you, normally you perform these two operations on the stack. One is the push, where the element is inserted into the stack, and another is the pop, where the element is removed from the stack. And always you will find that there is one pointer that will represent the top of the stack. So pointer will keep an address of the top element of the stack. So top will indicate that where the space is available so that the element can be inserted, or top is the memory address where it will indicate from where we can perform the pop operation. So for performing push operation and for performing pop operation, you need to know the address of the memory location, and that address of the memory location is being given by a pointer, and that is being called as the top of the stack. Stack, as I said, is a very useful data structure, and it is being used in many computer applications. Say for example, if you are writing some program where you are making the use of recursion, then in recursion, as we know that in recursion what we do is that we call the atom in the process itself. So when the process is called in the process itself, that is to be called as a recursion. So for the implementation of the recursion, what you require is a stack. Whenever you have been given a function call, we know that in programming we always make use of functions, and a function whenever is defined within a program, we need to call a function. So every programming language will provide you the facility through which you can call a function. So when there are multiple function calls, then keeping track of the function calls will be maintained by the stack memory only. If you have been given some expression, some mathematical expression or some logical expression, then you will find that the evaluation of the expression will make the use of the stack memory. So whenever in a programming language or in a program we write some complicated mathematical or logical expressions, then there is a certain system of evaluating these expressions, and for evaluation of these expressions we need to make the use of the stack memory. Also, whenever we make the use of hardware, then there are several hardware interrupts, or whenever you deal with the problem of backtracking, that is whenever you want to go back, isn't it, in the steps, if the certain things are not achieved, then in such logical situations you will find that the stack memory is very useful and people need to make the use of the stack memory. Now let us understand how this stack can be implemented in memory. As far as the stack implementation is concerned, it is a linear sequence of elements, and therefore we can make the use of array for the implementation of the stack. As shown in this diagram, suppose we have been given an array where we have one end which is being called as a closed end, and we have one end which is being called as an open end, and then we go on adding the elements into the stack, and every element is being assigned with some index number. Suppose my first element is 10, where the index is 0, second element is 20, index is 1, third element is 30, where the index is 2. And now you will find that I have an empty space. So whenever we have an empty space, then the top of the stack is being marked by the pointer called as the top. And you should make an access to this pointer top so that you can add some new elements into the stack. So whenever you add some new element into the stack, you will find that the stack will go on increasing, or the stack will go on growing in the upward direction. So stack is such a data structure where you will find that it is being not supported by the most of the programming languages. Programming languages normally support for array. Programming language normally supports for other basic data structures, but programming languages do not support for the stack. So there is no inbuilt stack data structure available with the programming languages. So if you want to use a stack within your program, then it is mandatory for you to make the use of array, because arrays are supported by the programming languages, but stacks are not supported by the programming languages. And therefore you can make the use of array for implementation of the stacks. Another way to implement the array is that you can make the use of the linked list. Linked list is also like an array, but the only thing is that every node in the linked list will have some kind of pointer, and this pointer will point to the next element. And therefore the advantage with the linked list is that it can be stored in any part of the memory, and by using the linked list it is possible that we can implement the stack. So the value of the index variable of an array can be assigned to the stack pointer. So whatever is your top, isn't it, the element, you will find that the index of that can be assigned to the pointer top, which will point to the top of the stack and which will indicate you which part of the memory is now available for storing the elements. So whenever we insert the new element into the stack, then every time what we need to do is that we need to increase the top pointer by 1. Observe that if you are storing some integer elements into the stack, then every integer will require 2 bytes. If you are storing some real numbers into the memory, then every real number will require 4 memory locations. If you are storing some characters into the stack, then every character will require 1 byte of memory. So accordingly, the pointer will be advanced by 1 byte, 2 byte or 4 byte, depending upon what type of the values are stored into the stack. And whenever we delete some element from the stack, then the element is removed. The element is removed means the top will be decremented by 1. So for integers, it will be decremented by 2 memory locations. For characters, it will be decremented by 1 memory location. And for float numbers, it will be decremented by 4 memory locations. So it is possible that you can create a stack of the fixed size by using an array. And if you want to have a dynamic stack where there should not be any restriction on the size, in that case, you can make the use of the linked list for the creation of the stack. So thank you friends for viewing the session. Hopefully you have understood what we mean by the stack and how the stacks can be formed by using array data structure. In our next sessions, we will discuss how to perform the push and pop operations on the stack. Thank you all for viewing the session.